All right, so now we're going to preventing foodborne and waterborne illness. If you haven't noticed, I wanted to point out that on the course page, I have also posted slides from a presentation that is designed not specifically for students, but generally for consumers about foodborne illness and food safety. And I think that it is a great resource to understand a lot of these same concepts, but it's presented again for consumers. It's sort of more friendly and fun, perhaps, than the way that the material is presented in the text. You are, of course, responsible for understanding the material from your textbook, but I think it makes some of this information just a little bit more easily accessible and understandable, and again, a little more fun. So you may want to check out those slides, and you can just kind of go through them pretty quickly, but I think get a good sense of both the reasons that it's so important to pay attention to prevention of foodborne illness, but also the steps that will help you to do that. But for now, we will talk about it from the perspective of your textbook. So some of the primary strategies for preventing foodborne and waterborne illnesses are just to practice good personal and kitchen hygiene. If you cough or sneeze or something like that, you want to wash your hands. You want to use clean surfaces and utensils, etc. Avoid cross-contamination, those types of steps. You also want to follow appropriate thawing, cooking, and storage procedures. So again, think about keeping foods out of that danger zone temperature, the temperature range as much as possible, and following the food safety practices described in this chapter. You also just want to know which foods pose an extra risk, so you can be mindful of that and especially careful in those cases. This figure from your text provides a handy list of those minimum safe cooking temperatures, and you want to have a basic understanding of what these temperatures are, so that you know generally how to ensure that food has been cooked to a safe temperature. This little diagram lists the 4 simple steps to food safety. And I know because of the way this is set up, the image, it's a little bit hard to see here, but it is on page 100 of your textbook. And basically what you want to remember are these 4 steps: clean, separate, cook, chill. And again, that clean has to do with washing your hands, but also surfaces and the knives that you're using, etc. Separate is don't cross-contaminate. So you can see here, again, I know it's small and I apologize, but that this raw meat is being cooked separately from the fresh produce so that you don't get any bacteria, etc. from the raw meat onto the fresh produce, which you might just be eating raw and not cooking. And then again, you want to cook to safe temperatures and then store by chilling to a low enough temperature to be preserving that food outside of that danger zone temperature range. We're going to talk a little bit too about environmental contaminants in foods. Most common include heavy metals such as lead and mercury, industrial chemicals such as dioxins and PCBs, and then agricultural chemicals like the pesticides or antibiotics that are used in producing food. Lead can damage every organ in the body, especially the nervous system and kidneys. It also impairs the synthesis of hemoglobin, so it can be devastating. And it is even more dangerous in children. It's toxic to their developing nervous system and can result in lower IQs, behavior issues, impaired coordination, growth, as well as hearing. And it can also predispose kiddos who are impacted to high blood pressure and kidney disorders. Sources can include home plumbing, lead-based paints. This is typically going to occur in buildings that were built prior to 1986, before regulations were in place to not use lead-based paints anymore. And also lead-containing containers like leaded crystal or pottery. Certain candies from Mexico may contain lead. Vegetables, if they were grown in contaminated soil, can be a source of lead in the diet. Certain dietary supplements can contain some lead, and some toys, again, usually it would only be older toys, but were painted with lead-containing paints. So these are things to watch because that lead can get into our food supply. Arsenic is a toxic element found in soil and water throughout the world, and it is a toxin as well as a carcinogen. It's linked to poor fetal growth, adverse immune and neurodevelopmental outcomes in both infants and children, and it can also lead to cancer in adults. So again, it's very dangerous. Rice, especially brown rice, is the major source of inorganic arsenic in our diets. There's a concern about using infant rice cereal. So in terms of limiting your exposure to arsenic, you want to feed babies and toddlers a variety of grains, not just rice, so that if there is some amount of arsenic in the diet, it's not going to be to an excessive amount in the baby's food supply. Consume white rice in place of brown rice occasionally is another recommendation. We know that in general, there are a lot more health benefits to brown rice because it's a whole grain. So this is something that I would say you don't want to go too far away from choosing brown rice. But again, mixing it up, if you tend to eat a lot of brown rice, that might be something to watch. And also cook your rice in excess water. As a strategy for sort of rinsing away some of that arsenic. Next, we're going to talk a bit more about dioxins and polychlorinated biphenyls, or PCBs. These are byproducts of industrial processes and incineration of waste, and they do increase the risk of cancer and can cause liver and nerve damage. They also may have adverse effects on reproduction and may increase the risk of type 2 diabetes. Food sources do include animal fats, but we usually associate this primarily with freshwater fish, which come from contaminated waterways. And a key guideline for fish consumption is variety and moderation. So again, mix it up a little bit. Don't consume too much of any one type of fish, in a short period of time. Mercury, in the form of methylmercury, can cause nerve damage, fatigue, and also poor learning abilities. Once again, fish are the primary food source in our supply. And those who are most at risk are children, pregnant women, and breastfeeding women. So that's why there are particular guidelines for these groups. Both FDA and EPA guidelines for at-risk individuals encourage us to not eat shark, swordfish, king mackerel, or tilefish, to limit albacore tuna to 6 ounces per week, and to limit the intake of fish containing less mercury to 12 ounces per week. And that includes shrimp, your canned light tuna, pollock, salmon, and catfish. And you also want to check the EPA advisories from local waterways. And again, these guidelines are for those groups who are most at risk, kiddos and pregnant and lactating women. Now we're going to talk about pesticides and antibiotics. There are 2 major classes, synthetic or biopesticides. Now, the earliest synthetic pesticides didn't break down easily, although those today do. But biopesticides were developed to provide safer alternatives. There are quite a few problems with pesticide use. So the intended organism, the one that the pesticide is designed to kill, they can eventually become resistant. You get pesticide drift, so crops that are not where the producers or farmers are not using the pesticides those crops do end up getting contaminated by the pesticides. They can be taken up by non-target organisms. They can enter the groundwater or aquatic habitats. They can be harmful to non-target species. So, for instance, if deer in the area are eating plants that have been treated with pesticides, just as an example. They can decrease biological diversity of plants, harm water quality, disrupt wildlife habitats, damage soil and nutrients, and contribute to erosion. So again, pesticide use is regulated. Responsibility is shared by the EPA, FDA, and USDA. The Environmental Protection Agency will determine if the pesticide is beneficial and does not pose health or environmental risks, and it sets the limits. USDA is also really important because it tests foods for pesticides and enforces the EPA pesticide tolerances. So if you want to minimize your exposure to pesticides, wash and peel your fruits and veggies, trim away the fat in your meat, and once again, you may be noticing a trend in this chapter. Select a variety of foods. Don't consume always the same type of meat, grain, or produce. Once again, infants and young children are a special consideration. They consume a relatively higher dose of pesticides per their body weight. So therefore, they may not metabolize the pesticides as readily as adults because their liver is still immature. So both the dose and the body's capacity to metabolize the pesticides can be a concern. In terms of antibiotics, these are often given to animals that are being produced for food in order to promote growth and prevent or treat disease in the animal. The concern is that the use of antibiotics will foster the growth and spread of antibiotic-resistant bacteria strains, and they're very difficult to treat because they are antibiotic resistant. So this last table gives you a summary of the different U.S. agencies that are responsible for ensuring a safe food supply. So again, you'll want to recognize that each of these agencies does have a role in maintaining food safety in the United States. So you want to recognize the role that each one plays. And that is it. Hopefully this gives you some good food for thought in terms of the choices that you make, in terms of the balance and variety and specific types of foods that you choose in order to maintain health and safety. Thanks, everyone. That's it for the quarter.